Hey everyone, and welcome. So today we are tackling one of the biggest, and let's be honest, one of the most frustrating problems in AI, hallucinations. But we're not just going to rehash the problem. We're going to dig into this really fascinating new paper that has a pretty radical idea. It says the solution isn't just throwing more data at the problem, but actually teaching AI a very, very human trait, the ability to doubt. All right, let's get into it. We've all been there, right? You ask an AI a question, and it spits back an answer that sounds so confident, so detailed, and is just completely, totally wrong. I mean, it's not just getting a fact wrong, it's creating this plausible-sounding story out of thin air. We call this a hallucination, and it is a massive roadblock to us actually trusting these incredibly powerful tools. So why? Why does this keep happening? You know, the standard answer is always, oh, we just need bigger models, more data, more parameters. But what if that's not the real story? What if the problem isn't about a lack of information at all, but a really deep, fundamental flaw in how these AIs are even built to think in the first place? And that brings us to the first big idea here. This new paper argues that hallucinations aren't just some random error, not a bug that you can just patch up. No, they're the natural, totally predictable result of how AIs are designed at their very core. So to fix it, we have to go way deeper than just some surface-level tweaks. Okay, so this slide really gets to the heart of the misunderstanding. We like to think of AI as this giant, super smart library, but that's not really how it works. A large language model is, at its heart, a probability calculator. Its only job, the only thing it cares about, is predicting the next most likely word in a sentence. So a hallucination? That's not pulling the wrong book off the shelf. It's just a string of words that has a really high chance of sounding right, whether it's true or not. So if the problem is baked right into the design, what exactly is it? Well, this is where the paper introduces this absolutely brilliant analogy. It says that current AI models see the entire world of ideas as being completely flat. And that flatness, that's the root of the whole problem. Let me show you what that means. Imagine all of human knowledge spread out on a giant, stretchy rubber sheet. For today's AIs, that sheet is perfectly smooth, perfectly flat. So if you ask it a question, let's call that point Q, it can always find a smooth, unbroken path to an answer, point A. It just stretches the sheet to connect the dots, even if that connection makes absolutely no logical sense in the real world. But here's the thing. Reality isn't a flat sheet. The world of ideas is rugged. It's full of holes, it's full of contradictions and paradoxes, these deep logical canyons that separate one idea from another. You just can't draw a straight line from Neil Armstrong to walking on the sun because there's a huge canyon of impossibility right in the middle. And current AIs, they're completely blind to these holes. And this is the paper's big aha moment. A hallucination is just the AI trying to pave over one of those logical holes that it can't even see. It's forcing a connection where one just shouldn't exist. It's not a failure of knowledge, it's a failure of topology. It doesn't understand the fundamental shape of ideas. It just can't see the gaps. Okay, so if that's the problem, how in the world do we fix it? Well, the paper proposes we need to build a totally new kind of AI, one that has a more rugged, a more realistic view of the world. And this means the goal has to shift, away from just predicting the next word to something way more profound, making sure an entire line of thought is actually structurally sound. And the new standard for this AI is a concept they call symbolic viability. The idea is that a thought isn't considered true just because the words sound plausible together. Instead, it's only viable if the whole structure of the idea can hold up under intense logical stress testing without any internal contradictions. It's a huge shift from just looking good to actually being solid. This slide really just lays it all out. We're moving from the old way of doing things, prediction, which is all about minimizing surprise, to this brand new topological paradigm. And here, the whole goal is to minimize inconsistency. The AI's job is no longer just to talk, it's to make sure that what it's saying is logically coherent from start to finish. So, to pull this off, the researchers propose a new kind of architecture called the Topological Inference Engine, or TIE for short. And you can kind of think of it as a supervisor that sits on top of the language model, a system designed not for creativity, but for a kind of computational, intellectual honesty. So, how does this thing actually work? Well, the TIE puts every potential thought through this really tough four-step cycle. First, the language model generates a bunch of possible answers. Then, the engine checks those answers against a database of known facts and logical rules. After that, it connects the dots and it maps out the whole logical structure of each answer. And then the final, crucial step, it measures the level of internal contradiction. And that measurement gives you what we can basically call a contradiction score. Now, the paper calls it a cohomological residue, but let's be real, the idea is simple. A score of 0 means the thought is perfectly coherent, totally sound. A high score, like this 1.73, means the thought is riddled with logical holes and contradictions. It's a simple mathematical way to spot a bad idea. And this is where it gets really cool. What happens if all the possible answers have a high contradiction score? Well, the TIE triggers something absolutely revolutionary called the kenosis operator. And this is, for all intents and purposes, an I don't know button. Instead of just guessing the least wrong answer, the AI is programmed to recognize the logical hole and just say nothing. It chooses silence over being wrong. And this brings us to the really huge implication of all this work. The next monumental leap for AI might not be about knowing more stuff. It might be about developing the capacity for doubt, the wisdom to know what it doesn't know. I mean, that is a fundamental shift from an all-knowing oracle to a truly intelligent, honest partner. An AI that can do this would be a total game changer. It could recognize a paradox and just flag it, instead of trying to confidently explain it away. It would stop itself dead in its tracks from generating misinformation. It could even tell you if your question doesn't make sense. It moves from just being a text generator to a system that can actually self-correct and show real intellectual honesty. I love this quote from the paper because it frames doubt not as a weakness, but as a form of efficiency. Think about it. It takes a lot of computational energy to force a connection across a logical canyon, to build that flimsy little bridge. An AI with doubt just recognizes when the cost is too high. It's more honest and, frankly, more efficient to just admit there's a hole there. And so all of this leaves us with a final, really provocative question. As we build these minds that are more and more powerful, maybe the most important thing we can give them isn't an encyclopedia of every fact in the world, but a structural understanding of truth, a respect for contradiction, and the simple, profound honesty to just say, I don't know.